All right, let's look at this think, pair, share activity. So a think, pair, share, you should think of this as maybe a problem that you work on your own first, and then you watch this video to see how you did. Um, think, pair, shares are activities that I usually do in the classroom where I have the students work together on a problem. All right, so let's go ahead and see if we can work this one out. So this is ice cream stand sales to adults and children. An ice cream stand at a county fair recorded inventory sold during the course of 1 week. The data is a contingency table. Calculate the probability if an ice cream cup is sold, then the customer is an adult. Okay, so how do we interpret that? So calculate this probability. If an ice cream cup is sold, then the customer is an adult. Another way of putting it is the probability that the customer is an adult given a cup is sold. So because of this rephrasing, and thinking of it in terms of the word given, this is a conditional probability. All right, so if we use letter A to represent the event of being an adult, and we use the letters CU to represent the event of a cup. So what's the probability that the customer is an adult given a cup was sold? So what we need is the probability that the customer was an adult given that a cup was sold. So now we need to use the formula for conditional probability, which is going to be the probability of the adult event intersecting with the cup event all over the probability of the cup event. And that is equal to the ratio of the order of the adult event intersecting with the cup event all over the order of the cup event. So what's the order of the adult event intersecting with the cup event? Well, let's maybe draw these up above here. So the adult event, actually, let me go ahead and use colors here. So the adult event is going to be this row here, and the cup event is going to be this column here. So where's the intersection of those two? Right here, 592. Now, what's the order of the cup event? Well, the order of the cup event is going to be this entire column. And so 492 plus 410, that comes out to 1002. So that's going to come out to, if you do that on your calculator, 0.591. So the probability that the customer is an adult given that a cup was sold is 59.1%. All right. Let's look at the next question. Okay, the probability that the customer was a child. Well, let's see. What is the child event? What does that look like? Well, the child event is this entire column right here. So if we were to go ahead and calculate the sum of this entire row, then the order of the child event is going to be 1000. All right, so the probability that a customer was a child is the order of the child event all over the order of the sample space. And the order of the child event we already put is 1,000. And what was the order of the sample space? Well, we could, add across this row, and we've already added across this row, and add the two together. That would give us our grand total. But we were told up here that the inventory that was sold was 2,200. So that's our sample space, 2,200. So that'll come out to 0.4545. So the probability that the customer was a child is 45.45%. Okay. Let's go down to question 3. So the probability of a child customer or a cone was purchased. All right, so this is going to be the addition rule. So we need to figure out, are we going to use this formula? Okay, the probability of child or cone is equal to the probability of child plus the probability of a cone. And that would be if the two events are disjoint, or the probability of a cone, child or a cone, if it'll look like this, where we have to subtract the probability of the intersection between those two. And that's if they are not disjoint. All right, well, let's see where these are. So we've got our child event here, and then our cone event here. So we can see that we do have an intersection, which means we're looking at this non-disjoint equation that we need to use. Okay, so the probability of the customer being a child or cone being sold is the probability of being a child plus the probability of a cone being sold minus the probability of a cone child intersecting with a cone. Sorry about that. All right, so this will be the order of C over the order of the sample space, plus the order of a cone over the order of the sample space, minus the order of the intersection between child and cone over the order of the sample space. Well, see here, we know that the order of the sample space is 2,200. Let me scroll down, give myself a little bit more room. All right, the order of the child row, I think we said from the previous example that comes out to 1,000 exactly. Okay, so we had 1,000 children that day. How about the order of a cone? So that's going to be the total here in this cone column. So 300 plus 335 is 635. And the order of the intersection between the child event and the cone event is 335. All right, so let's see here. We can kind of do this in parts. So 635 minus 335 is going to be 300 over 2,200. And then 1,000 plus 300 is going to be 1,300 over 2,200, which reduces to the ratio of 13 over 22. So the probability of child or a cone is the fraction 13 over 22, which should come out to 0.591 or 59.1%. Okay, so this concludes this think, pair, share. Let me know if you have any questions.